Hey, welcome back. In this tutorial, we are going to learn another useful and interesting function, that is the clock function. The clock function is given in the header time.h. Now when called, this clock function returns the number of ticks that your processor does since the beginning of execution of your program. So as you can see that I have made a call to this clock function at line number 9, and it's going to return a long integer that I am assigning here in this variable tick1. So this variable tick1 is going to hold the number of clock ticks that the processor does in my machine since the beginning of this particular program. So here we are printing that tick1 to see what's the number of clock ticks for this particular clock call here at line number 9. Let's go ahead and run this. You can see that it's actually 1. The number of clock ticks since the beginning up to this call is actually 1. Now we can use this clock function for finding the execution time of a particular function or a portion of a program. Let's go ahead and see how we can do that. For this purpose, I'm going to use this particular function that's going to return the Fibonacci term of the Fibonacci series. And I already have explained this function earlier when I taught you the recursion. I have explained this function in depth, right? So if the value of t is 1, then it's going to return the first term of the Fibonacci series. If the value of t is 2, it's going to return the second term, and so on. So this is a recursive function, and we are going to make a call to this function several times to get the Fibonacci terms. Here we go. We are actually going to find out the sum of, say, first 30 Fibonacci terms. So I have that variable sum here, and that should be a long one. And then we have this loop counter that is starting from I equals 1, and we should go up to, say, 35 elements. That's okay. And then we are actually having the sum of the Fibonacci's terms. So I'm passing I there. So when I'm passing I as 1, it's going to return the first term. I as 2, it's going to return the second term, and so on. So we are going to accumulate the sum of each of the terms of the Fibonacci series. And then we are incrementing this loop counter I. Just before entering into the loop, we are actually getting the clock tick here in this variable tick1. And when we are done, we are actually again going to get the clock tick in another variable. So the subtraction between this tick2 and tick1 is going to get us the number of clock ticks for doing this particular loop, right? So long elapsed equals tick2 minus tick1. Let's print this and see how many clock ticks were actually used for doing this particular processing. So here we go, %ld and then \n and then elapsed. Okay, let's go ahead and run this. You see that it took actually 151 clock ticks. Now this is not the number of seconds. Now please remember that this elapsed is not the execution time. It's not in seconds. It's actually number of clock ticks. So in order to find out the elapsed time, you'd require to divide this particular clock ticks with a constant that is called clocks per second. Now this clocks underscore per underscore second is the number of clock ticks in a second. So in order to get the execution time, you'd require to do in this way. That is the elapsed clock ticks, and we are dividing that by this clocks per second, and we are getting that result here in this double variable. So this particular double variable elapsed underscore time is going to hold the number of seconds that was taken by your processor and the system altogether to perform this particular while loop. And we are printing that here. So let's go ahead and run this. So you can see that it's 0.15 seconds and with 150 clock ticks. So that's how you can find out the execution time of any program or part of program or a particular function. I hope you have enjoyed this particular lecture. Thank you very much for watching.